Ohio, but they're half of the special needs cases. Like the Miller children, the mysterious crippling disease that affects 3 of these 5 brothers and sisters has no name and no known cure.
In the heart of America, where time moves slower and traditions never fade, a quiet secret lingers. The Amish, famous for their simple way of life, have lived apart from the modern world for centuries, but isolation comes at a price. What happens when a community stays genetically closed for over 300 years? When the same names appear in family records again and again? The answer lies in their DNA, hidden, silent, and shaping generations in ways few outsiders ever realize. But to understand this, we need to look deeper into their history, their way of life, and the science behind a gene pool that never truly opens. The science behind Amish inbreeding. Inbreeding happens when close relatives have children, increasing the risk of genetic disorders. Normally, genetic diversity helps prevent harmful mutations from surfacing, but in closed communities like the Amish, this protection weakens over time. The Amish have lived in genetic isolation for over 300 years, strictly marrying within their circles. With a small number of founding families, their gene pool remains limited. This lack of new bloodlines means recessive traits, normally rare in larger populations, become far more common. Medical researchers have studied these effects extensively. A Johns Hopkins University study found that certain genetic disorders, like Ellis-van Creveld syndrome, which causes dwarfism and heart defects, occur at significantly higher rates among the Amish. Another study by the University of Pennsylvania identified rare metabolic diseases almost exclusive to these communities. This pattern isn't unique to the Amish. It has been observed in other isolated populations. But because the Amish maintain detailed genealogical records and avoid modern medical interventions, scientists can trace these genetic conditions more clearly. Understanding their genetics isn't just about history, it's about recognizing how isolation shapes the health of future generations. But how did the Amish end up in this situation? To answer that, we must go back to their origins. Hidden genetic disorders in Amish communities. When a population remains genetically isolated for centuries, certain rare conditions become far more common. Among the Amish, generations of intermarriage have led to a higher occurrence of inherited disorders, many of which are almost unheard of in the general population. Ellis-van Creveld syndrome. One of the most well-documented Amish genetic disorders is Ellis-van Creveld syndrome, a condition causing short stature, extra fingers, and severe heart defects. It was first studied in Pennsylvania's Amish communities, where researchers found it to be significantly more common than in the general population. Studies from Johns Hopkins University have shown that this disorder stems from a recessive mutation passed down from a small number of Amish founders. Children born with this syndrome often require early heart surgery, and while some can live normal lives, others face serious complications. Maple Syrup Urine Disease, MSUD. Another disorder seen at unusually high rates in Amish communities is Maple Syrup Urine Disease, MSUD, named for the sweet-smelling urine it causes. This rare metabolic disorder prevents the body from breaking down certain amino acids, leading to toxic buildup in the bloodstream. If untreated, it can cause brain damage, seizures, and even death in infants. According to research from the University of Pennsylvania, Mississippi UD is nearly 200 times more common in the Amish than in the general U.S. population. Crigler-Najjar syndrome. A lesser-known but equally severe condition found in Amish communities is Crigler-Najjar syndrome, a disorder affecting the liver's ability to process bilirubin, leading to severe jaundice. In extreme cases, it can cause brain damage if not managed, with lifelong treatments like phototherapy. This disorder is another result of the Amish's restricted gene pool, with studies showing its presence in multiple families across different settlements. Rare immune and metabolic disorders. The Amish also experience higher rates of glutaric acidemia, a metabolic disorder that can cause brain damage, and cartilage hair hypoplasia, which leads to short stature and immune deficiencies. These conditions are so rare elsewhere that they have become key study subjects for genetic researchers. These disorders highlight how genetic isolation impacts not just history, but everyday life. However, the Amish have also developed ways to cope with these conditions, often relying on traditional remedies and community-based care. But what happens when modern science steps in? That's where things get even more interesting. Why Amish genetics are different from other communities. The Amish gene pool is unlike almost any other in the modern world. While most populations continually mix with outsiders, introducing new genetic traits, the Amish remain genetically isolated. This has led to a unique phenomenon known as the founder effectone of the key reasons genetic disorders are more common in their communities. The founder effect. The Amish are descendants of a small group of settlers who arrived in North America from Europe in the 18th century. This original population was estimated to be only a few hundred individuals. Over generations, their descendants inherited the same genetic material from these early founders, including rare recessive mutations. Because Amish communities discourage marriage outside their faith, these genetic traits, both good and bad, were passed down repeatedly. Over time, disorders that were once rare in the original settlers became widespread. This is why conditions like Ellis-van Creveld syndrome and Maple Syrup Urine Disease are seen at significantly higher rates among the Amish than in the general population. A closed gene pool. Unlike most other populations, where people from different backgrounds marry and introduce new genes, the Amish strictly marry within their own circles. While this preserves their cultural traditions, it also prevents genetic diversity. With each generation, the same small set of genes is reshuffled, increasing the likelihood that two carriers of a recessive disorder will have affected children. Scientific studies have shown that many Amish settlements trace back to just a handful of common ancestors, meaning entire communities share a higher than average number of genetic similarities. This isn't unique to the Amish, it happens in other isolated groups, such as the Ashkenazi Jewish population, but because the Amish remain separate from mainstream society, the effects are more pronounced. Limited medical intervention. Another factor that sets Amish genetics apart is their approach to healthcare. Many Amish prefer natural remedies and faith-based healing over modern medicine. Some families avoid hospitals altogether, relying instead on traditional treatments and midwives for childbirth. While this reinforces their way of life, it also means genetic disorders often go undiagnosed or untreated for longer periods. Despite these challenges, Amish communities have adapted in their own ways. Some have even begun working with genetic researchers to better understand and manage inherited conditions. But what happens when modern science and old traditions collide? That's the next part of the story. How the Amish handle genetic diseases. The Amish approach to genetic health issues is shaped by their beliefs, traditions, and way of life. Unlike most communities, where modern medicine is widely accepted, the Amish take a more selective approach. This has led to an ethical debate. A matter of faith and tradition, many Amish families rely on traditional remedies and home-based treatments instead of seeking medical care. This stems from their deep religious beliefs, which emphasize self-sufficiency and a simple life. Hospitals and modern treatments are often seen as unnecessary or even intrusive. While some Amish do seek medical help in emergencies, many prefer to handle illnesses within the community. This approach raises concerns. Some genetic disorders, such as Maple Syrup Urine Disease, require urgent medical intervention to prevent brain damage. But in many cases, treatment is delayed or refused entirely due to religious or cultural reasons. Selective treatments. Despite their general avoidance of hospitals, some Amish communities do accept certain medical treatments, but only when absolutely necessary. For example, children born with Ellis-van Creveld syndrome often receive life-saving heart surgery, but their extra fingers may not be removed since it is not considered a life-threatening issue. However, many still reject treatments that require long-term dependency on modern technology, such as insulin for diabetes or ventilators for respiratory diseases. The question arises, is it ethical to allow children to suffer from preventable conditions when medical solutions exist? The role of genetic testing. Some Amish communities have started using genetic counseling to identify at-risk marriages and reduce the chances of passing on inherited diseases. A few groups even allow genetic testing before marriage, helping young couples make informed decisions. But not everyone agrees with this approach. Some Amish believe that genetic testing interferes with God's will, while others see it as a responsible way to protect future generations. This raises another ethical dilemma. Should science play a role in Amish traditions, or should their way of life remain untouched? Ultimately, this debate has no simple answer. The balance between faith, culture, and science is delicate. The Amish continue to navigate this challenge in their own way, but as medical knowledge advances, the pressure to adapt will only grow. Should the Amish change their ways? The Amish way of life is built on faith, tradition, and self-reliance. But as genetic disorders become more prevalent, a difficult question arises: should the Amish introduce new bloodlines to prevent disease, or should their traditions remain untouched? Genetic counseling versus tradition. Some Amish communities have started embracing genetic counseling, allowing couples to test for inherited conditions before marriage. This approach helps prevent high-risk unions and reduces the chance of passing on serious disorders. Medical researchers see this as a responsible step toward healthier generations. But for many Amish, genetic testing contradicts their faith. They believe that life and health are in God's hands, and any attempt to control genetics goes against divine will. Changing their Tradition 7 for medical reasons would mean compromising the very values that define their identity. A question of rights. This raises a larger debate. Should outsiders intervene? Some argue that genetic disorders in Amish communities are a public health issue, especially when affected individuals require specialized medical care. Others believe that forcing intervention, whether through medical policies or government mandates, would violate Amish religious freedom. Medical organizations and advocacy groups face a dilemma. Do they have the right to pressure the Amish to change, or should they respect their choices, even if it leads to suffering? Survival versus belief. If genetic disorders continue to rise, will the Amish be forced to adapt, or will their commitment to tradition remain unshaken? Some believe that small changes like genetic counseling could help preserve both their health and their culture. Others fear that any compromise may lead to the gradual erosion of Amish identity. For now, the Amish remain in control of their own fate. But as science advances and medical challenges grow, how long can they hold on to their ways? The future. Can the Amish avoid a health crisis? For centuries, the Amish have lived by a simple rule-marry within the community. But as genetic disorders become more common, some are questioning whether this tradition can continue unchanged. Can the Amish prevent a health crisis without sacrificing their identity? One possible solution is allowing limited outside marriages. If even a few non-Amish individuals were welcomed into the community, it could introduce genetic diversity and reduce the risk of inherited diseases. But for most Amish, this idea is deeply controversial. Marrying within their faith is a core belief, and allowing outsiders in, no matter how beneficial, could threaten their cultural identity. Would they still be Amish if they changed this fundamental rule? Some Amish communities are taking a different approach. Instead of changing who they marry, they're changing how they prepare for marriage. Genetic testing is now being used discreetly in some groups, helping couples avoid high-risk unions. By identifying carriers of severe diseases before marriage, they can protect future generations. In some cases, Amish families are also partnering with medical professionals, creating specialized healthcare programs that respect their traditions while addressing their unique health challenges. If nothing changes, will the Amish face a worsening health crisis? Some researchers warn that without intervention, genetic disorders will only become more frequent. Others believe the Amish will find a way to adapt while holding on to their traditions. The future remains uncertain, but one thing is clear: the choices made today will shape the health of the Amish for generations to come. Amish inbreeding isn't a myth, it's a scientifically documented issue with real consequences. Generations of genetic isolation have led to rare disorders becoming alarmingly common. While some Amish embrace genetic testing and medical advancements, others resist holding firm to their traditions. This isn't just an Amish issue. Other small, isolated communities around the world face similar risks, from remote island populations to royal bloodlines of the past. History shows that genetic diversity is key to survival, but how much change is too much? The Amish stand at a crossroads. Can they find a way to preserve their identity while protecting future generations from preventable suffering? Or will their commitment to tradition ultimately become their greatest vulnerability? In the end, the question isn't just about genetics, it's about survival. When does tradition stop being a foundation and start becoming a trap?